Hello everyone. My name is Phan Nguyễn Kỳ Phúc, and I will be the lecturer of the course Introduction to the Scheduling and Sequencing. And since this is our first class, so basically, our first class will be divided into 4 sections. In the first section, I will share with you my information and also the context. So in case that you need my help and also need discussion, you can contact with me, right? And in the next step, we will consider about some basic definition and conception in the scheduling and sequencing. In the next section, we will consider about some important characteristics and constraints that we need to focus or pay attention to when we need to set up the model for the scheduling and sequencing. And finally, it's about the performance measurement and objective, which means that when we try to set up the model for the scheduling and sequencing, so what is the objective, what is they consider, need to pay attention most at our objective. And so this is my information. So this is my name, Phan Nguyễn Kỳ Phúc, and this is my email. Right, so please remember it's in this case that you need to discuss with me, you can send me email first, and this is also my telephone number, and I will stay in the 82107, right? So some of the time, so in case that you need to find me to discuss, right, and you need me to consult, you can go directly to my office, right? And during this course, we will use the book of Pinedo, Scheduling and Theories, Algorithm and System of the Springer publisher, right? And the first one that I want to emphasize you that so most of the time I already prepared the lecture notes for use. So the lecture note will be under something under the form like this. So this will be the summary of the content of the course, right? And so I think that most of you should be download it on the Blackboard system. I already upload on the content of the course on our Blackboard system, and then you should bring down and bring it, and you can take note on this, so it will save your time and you will have more time to listen to or to focus on just the main point of the content of the class, right? So here now, before we go to further, right, so first of all we need to understand about the contents of this course. So basically scheduling, sequencing and planning, it's just one of the terms usually that refer to the action of planning. So here planning is, so how can we assign the job, or how can we arrange the job in some specific order. That, and when we assign some job in some specific order, it must satisfy some constraints, and when we satisfy some constraints, it will improve the performance of the whole system. It may be the, we can reduce the cost, reduce the money, reduce the worker number of worker. We can reduce, we can increase the throughput, and we can reduce the total completion time of the whole system, right? So basically, planning and sequencing is the main objective is to assign or to arrange the job into some agents so that we can utilize the resources in the most effective way, right? And now before we go to further, now we can consider some basic definition about a job, right? So here job in general term that you must understand that is something that we must be finished, right? And when we process it, we must be finished. And when some job is processed, it usually that it will take some resources. These resources may be machines, labor, or money, right? And now here, for example, when we consider about a job, we usually have the common attribute like this. The first one will be the processing time, right? processing time Pij represent for the time chip J has to spend on machine I, right? And the next one will be the release day. The release day of the one chip is also the know that at the day that the chip is ready, right? It means that when the chip is ready, this means that it can be processed immediately, right? So to be ready, it must have satisfy some previous constraint, and also it must satisfy that, for example, it had already have the enough labor or machine or something like this for the job, right? So here we can back to the our notes here, right? So we have this here. This is the definition for the release date of the job. This is the time that the job arrives at the system, and this is the early time which job can start its processing. And here we also have another information is about the YWJ, right? So the YWJ is the priority factor reflecting the importance of job relative to the other job in the system, right? So here maybe sometimes you can interpret it as the benefit, right? So it means that okay, one job will have the more weight, it may create more benefits than the other job in the system, right? And here we also have another relating to job about the dynamic data, right? Here we have the starting time and completion time of the job. So here the starting time, if you look at the notes, will be, this means the time when the job is processed on the machine, and completion time is the time when the job is completed on some machine, right? So this is basically some most common characteristic that we need to consider when we try to model and solve the scheduling and planning problem, right? And here relating to the machine, we will have the machine configuration is relating to physics. About that we have single machine that on the chart that must be go to the only one machine, parallel machine, and right. So here before we go to further concept, now we need to understand about the idea of the machine very clearly. So here basically machine that mean that some agents that will process the job, right? So this machine may be human, it also a real mechanical machine, or some process that will require time to handle the job, right? And when the one job go to some machine, usually that it will be on for certain period of time. This will be the processing time of the job on the machine. So the machine will have a very broad or widen or very wide meaning. Not just will be narrowed down in the meaning of the real mechanical machine or electronic machine, right? And here the second one that I will talk about is the parallel machine model. So here in the parallel machine model, sometimes we will have some idea that when we increase the machine, right, we can improve the whole throughput, whole productivity of the whole system. Basically, it will be a tool. But let's see how can the two identical machine can be reduce the processing time of one job. For example, here if we have if one job can be handled by several machines at the same time, right? So this guy that the job can be handled on several machines at the same time. So the processing time of it will be reduced by the original processing time divided by n, with n is the number of machines. So in this case that the work can be shared among the machine. In this case that the work cannot be shared by among the machine. So if we have only one job and we increase several machines, right? So the processing time when the job go to this kind of machine will be cannot improve anymore. So here This is one important concept that when I teach another student in the previous class, they usually misunderstand about what is the role of parallel machine, right? And here we also have the flow chart model and chart model and supply chain model. So in the flow chart model, job have to undergo multiple operations on a different machine. And if the root of all jobs are identical, this means that all jobs visit the same machine in the same sequence. The environment is referred to as flow chart. For example, here if we have the job A, B, C, D, and on the job A, B, C, D, they must go to the machine 1, 2, 3 according to the sequence. The first one machine will be machine 1, second machine will be the machine 3, and the third machine will be the machine number 3, right? So they must have the same root, so we have the in case of flow chart model. And the second one that we are interested in is about the job chart model. So here, job chart model. In multi-operation shop often have a different route, right? So this kind of environment we call it the shop model. For example, if we back to the previous example, now we have three shop A, B, and C, right? And shop A follow the route of machine 1, machine 2, machine 3. Shop 2 not follow the same route like this, but it follow much machine 3, 1, and 2. So in this case that we have will be the chart model, and we also have the supply chain model. And in supply chain model, we focus on the actual production plan in various facility as well as on the transportation of products within the network. Usually that the supply chain model will be have a different cost about the supply chain model and design and also the logistic design, right? And now we consider about us most common characteristics and constraints that we need to be focused on when we need to build up the model for the scheduling and sequencing. So I need to back a little bit at the here, right? So here we have the first one, we have the precedent constraints, right? So here I need to back a little bit about the here. So now let's see what is the precedent constraints, right? So here precedent constraint, that means that for example, in scheduling problem, a job often can start on only after a given set of other jobs have been completed, right? And in such constraint, that refer to the precedent constraint, and it can be defined by a precedent constraint graph, right? And here that means that okay, job A just can be start, for example, only after the job B and job C already finished, right? So here B and C will be the precedent constraint of job A, right? And now we also have the machine electricity constraint. So that means that some job can only be operated or only be processed on some specific machine, right? Other machine cannot be handled or can be processed this type of job. So we have the machine electricity, right? And the one thing that we usually that we need to consider in the scheduling and sequencing is that the precedent constraint usually that can be represented by the direct graph, right? Like this. So here we have this job can only be done after the precedent job here already be finished, right? And we also have another about the workforce constraints, right? So here, right? So in case that a workforce constraint machine often require one or more specific operator to process a job, and also a facility may have only a few people who can operate such a machine, right? So the number of labor that can operate machine will be limited, and which will be create the workforce constraints. And we also have the routing constraints, right? So routing constraints maybe we usually meet it in the flow shop and the job shop. That means that one shop must be follow some specific rule, right? And we handling constraint, right? A material handling system enforces a strong dependency between the starting time of any given operation and listen time of its predecessor. Moreover, the presence of a material has often limit the amount of buffer space, which limit the amount of work in process. So here usually that we can think about the capacity of work in process, right? And we also have the sequence dependent setup time and cost. That means that, for example, let's consider we have the one machine M, right? And we have two job A and job B that needed to process on the machine 1. Now if job A is finished and then job B will go to the machine, right? So it will incur the setup cost. That means that and this setup cost of job B will be depending on which job is already finished before on the same machine. Here in this case will be job A, right? For example, in this case, if the job B and job B will be if previous job B is also another same kind of job, usually setup time will be not incurred because we use the same condition of operation on the same machine. So it's not will be incurred the setup time and setup cost, right? So sequence dependent will be the most and very easy to meet or encounter in the research relating to scheduling and planning, and it's one of the most difficult to handle, right? And the next one we are also consider is about the storage space and waiting time constraints, right? It's usually that it relating to the work in process storage is limited, right? This will be put on upper house on a number of jobs waiting for a machine. Usually that needs it will be set up the capacity for the buffer between two machines. And we also have the make to stock and make to order. Usually that it will be relating to the strategy, right? And we usually that we not really handle this kind of problem in the scheduling and planning. And here one thing that's maybe very important is the property of preemption, right? So what is the preemption? Sometime during the execution of a job, an event occurs, and that forces the scheduler to interrupt the process of that job, right? In order to make the machine available for another job. This happens when a rush order with given high priority enter the system, right? And the job take up the machine is said to be preempted. So here one thing that you need to pay attention to, right? So basically that means that, for example, if job A they have the processing time of 2, right? And when they already pass half of the processing time, for example, it already take 1. After that, by some reason, the process will be stopped, right? And now, when the process will be stopped, so job A on the machine is still not be finished because it just only have a half of time. So in case that when they restart the process, so if job A need only the rest of the time to finish of this, right? So we can think that job A can be a preemption job. Otherwise, it will be non-preemption. That means that when they just finish job A, when they already process the job A, it must be done from the beginning up to the end. No interrupt are allowed during the processing time or during the process. And we also have the transportation constraints. Usually that transportation constraint will be related directly into the supply chains model. And usually that we not consider it very clear, it's very carefully in scheduling and planning. Now, the next session that we are go to will be the performance measurement and objective, right? So now here, one of the most common that we are consider performance index that we are consider in the scheduling and sequencing is the minimum completion time. So the first of here. So for example, we have n sharp with a number from 1 up to n, right? And when one sharp is finished, for example, we will have the corresponding completion time C1 up. So n sharp we have n completion time, right? And our objective function is we want to minimize the completion time of top 1, top 2 up to top n. This means that the completion time of the whole system will be minimum, right? And this the completion time of the whole system we usually call it as the max span, right? And will be the maximum up on the C1 up to Cn, right? So you can consider the notes to get my idea. And the next one that we are consider we relating to due date, right? So that this means that the day that we are promised at the beginning that we will finish the job, right? And here we will have the two important performance that relating to the due date. The first one will be relating to the lateness, right? So lateness of one job will be completion time minus the due date. For example here, right? If you have promised you will finish the job at the day 10, and the real completion time of you is day 12, right? So the lateness will be 12 minus 10, it will be equal to 2, right? And here we want to set up the minimum, the maximum, the lateness of on job, right? Here. Sometimes we are finish the job, right? Sooner than the due date. So in this case that the Cj minus Dj here will be become to negative, right? So in this case that the maximum like this we will create a little bit how to say counter your intuition. So by this we define something like the tidiness. It will be Tj max Cj minus Dj in 0. So the tidiness will be always greater than 0, greater or equal to 0. And we also have the we can exciting some way with the total tardiness, right? And another thing that we consider is also the setup cost, right? Right. So the setup cost is depend a lot on the case of whether we have a setup dependence, Right, so as I already say here, we have the sequence dependent setup time and cost. So setup cost usually not related to this kind of problem. And we also have the WIP work in process inventory cost. So how long and so how many that work in process we have, right? And sometimes work in process can be easily damaged or become obsolete. So we don't want so learning to produce the WIP is too much. And we also have the finished good inventory cost, and we also have the transportation cost, right? In here, now we return a little bit. So basically today I already introduced you some basic idea, right, about the production scheduling and planning, um, right? And so now maybe you can go to the end of the notes. So in another note, I also have some assignment like this for you. So yeah, you can done it by yourself, right? So here, now I go to a little bit, go to the explain a little bit to the assignment. For example, here now we have the set of chart, right? For example, 1, 2, 3, 4, 5 up to 18, and we also have the present time here. In this case, it will be measured by the quick, right? 1, 2, 3, 4, 5 like this, and we also have the predecessor, right? It's given by the this here maybe. So here job 2, sorry, job 3 can only be done when the job 2 already finished, right? So by on this we need to find what. Now let's return to the note, right? First of all, you are asked to write the precedent contains graph, right? You can make a reference to here to draw it by yourself. The second one, you are asked, right, to compute the max span of the project, right? So the completion time, maximum completion time of the job here, right? And also you are also asked to by your own calculation. If it would be possible to shorten one of the jobs by 1 week, and which job will be done, right? So here, I hope that you can learn it well, because the content of this is also included in another class. I think that in the production management, right? Thank you, and hope to see you in the next class.